Okay, so guys, again, let's start. Again, same one router you have. So in a networking, like we have one famous attack, synchronized flood attack. So your attacker is trying to send synchronized message. Like we have three-way handshake, synchronize egg, and desynchronized acknowledgement again. So your clients repeatedly is sending synchronized message with some different IP addresses, different port numbers again multiple times. The packet will reach to your router. The router is trying to process the data and again is trying to send acknowledgement packet and is waiting for the reply packet from the client side. But client is our taker, but repeatedly is trying to send a synchronized attack continuously. 1,000, 2,000, 4,000, and your CPU in your router, your CPU is going to allocate to that one process like okay, execute the traffic and again send the acknowledgement and wait for the reply. This process is continuing is going on. So after 5 minutes, 10 minutes, after 1 hour, after 2 hours, your CPU is going to reach to the high 100%, and your storage, like you are receiving synchronized message, you have to store somewhere, so your memory is going to consume. Like in the router, we have some limited storage. We don't have no TB and GB and like I told you, like we have 512 MB something we have, and in that 512 we have our operating system, we have our running configuration, we have some different configurations also, and we are receiving that synchronized attacks, and also we are receiving some routing tables. So all the data is consuming your memory. So suppose your memory is reached to the 90%, 95%, 80%, 99%, 100%. When your memory is to the 100%, your CPU will reach to the 100%. Your system is going to crash. Your system is going to crash, so no one can send any packet from inside to outside. Synchronized flood attack. As I told you, like we are sending some message. Tomorrow, when we discuss about three-way handshake, then I'll show you what in this scenario we are doing three-way handshake attack. I'll just give you a. So it means your user is trying to send multiple traffic, and the multiple traffic is trying to send some synchronized attack, synchronized message, or you can say like it's trying to send ICMP packet. ICMP, everyone knows what is ICMP there. So your client, your attacker is trying to send multiple ICMP packet. In the ICMP packet, by default, we have 36 bytes of data, but after some time, like we can modify our data. I can change my size, like I can change my datagram size from 36 byte to the 1,000 byte or 2,000 byte. We can change, and we can send multiple traffic. Like generally in the router, we are sending 5 data, but we can modify with the 5 to 10, 100, 1,000 of that data we can send. So it means I am sending 1,000 of ICMP requests with the 100 bytes of data. In one packet, we have 1,000 bytes. So all the packet will reach to the your router. It means your ICMP packet is going to consume your CPU speed, CPU memory, then your bandwidth and so on. So we have to overcome this kind of scenario. So I can limit this traffic. It means I can tell my router, you have to receive ICMP packet in 1 second, only this much amount of data. If like I can say like I want to receive only 100 bytes of data per second, or in one packet, I want to receive only 100 bytes of data, not more than that. If I am receiving more than that, drop that packet. So we have this kind of scenario. We can limit the speed, we can specify the speed, we can specify the protocol, and we can use it. So this is your quality of service. In this firewall also we have this thing. You are using the access list. With the access list, what we are doing, we can filter our traffic. So this is also one kind of quality of service. With the access list, we can filter our traffic. Here we can manage our bandwidth, we can manage our CPU speed, we can manage our clock speed and all. With the access list, we can manage our networks traffic. So for managing in the quality of service, we have 4 to 5 mechanisms. We have classification. Let me open my bytes. We have classification, marking, then policy. We are limiting packet 100 KB. Per second, if I can say like per second, I want to receive only 1,000 of data. First of all, delivery. And also we can specify like when any user sending the synchronized attack, it means your memory is going to full with the synchronized message. So with the quality of service, we can set like when my buffer is going to full with the 50%. So after the 50%, if you are receiving any packet, so just check in your buffer, we have any low priority data or not. If we have any low priority data, drop that packet. So first, this is your quality of service mechanism. We have a classification. We can classify our protocol and our policies. Like in this scenario, I'm going to give one example. In that example, I'm going to classify my ICMP protocol because I'm going to mark that protocol. Then in the classification, we can classify our data. In the marking, we can use some then like it's a high priority, low priority, and what kind of priorities we are going to give. Then we have a congestion management and the congestion avoidance. Scroll down. Also, I told you like we can allocate some speed. Like for the voice data, I can allocate some 500 kbps speed or 1 Mbps speed for the voice and the video traffic. But suppose in your environment, the multiple users are sending the voice data and the video data. I allocate only 500 kbps speed for the voice and video data. If multiple users are trying to send the voice and the video data at the same time, so again, the link is going to consume by this voice and video data. So again, we have some queuing delay. So here, what we can do, where in your system we have one buffer. In the buffer, your all packet is going to store one by one. When in your buffer is going to divide it into 3 layers, minimum, maximum, and the filling. Like you can say that 40% is normal range, 60% is like 50% or 60% our data is filled. After that, if you are receiving the multiple data, so maybe your buffer is going to full. So we can set some range. When my buffer is going to full till 70%, then we have to check in your buffer, do we have any minimum priority, like less priority data or not? If we have any least priority data, drop that one. So we can like this, we can avoid to fill full our buffer. It means if your buffer goes full, suppose your buffer goes full like this, and you are receiving some high priority data. We don't have any space to store that data. So when your buffer is going to full till 70%, so we have some mechanism. Based on that mechanism, we can remove that least priority of data from our buffer. Then we have some space to store our higher priority data. So with the congestion avoidance, we can do these things. Then we have policy and the setting. In the policy, as I tell you, like I want to receive 1,000 bytes of data per second. Suppose I'm sending like, this is my data. In my router, I'm going to send some limit for the ICMP. I want to receive only 1,000 bytes of data per second. Suppose some user is trying to send, or multiple users are sending the ICMP packet. It means we are receiving more than 1,000 bytes of data for the ICMP. So in the policy and the shaping, in the policy, when like here, this is our range, this is my range, okay, and I am receiving some data. This is my range. With the policing, if I am receiving higher than that speed, like I said, 1,000 bytes of data, and I'm receiving more than 1,000 bytes of data, so we have to drop this packet. extra packet we have to drop. In this scenario, in the policy. In the policy, we have to drop extra data. I said 1000 byte of speed, it means done. If I'm receiving more than that packet, more than 1000 byte of data, we have to drop extra packets. But with the shaping, same concept, but is not going to drop that packet, is going to store in the queue. This is the difference between the policy and the shaping. In the policy, is going to drop extra packet, but in the shaping is going to put in the buffer and the queue. And when your CPU got free, then it's going to process the data. Okay. So this is your quality of service mechanism. I'll give you one example for policy. In CCNA, we don't have any like practicals, but I'll give you one. I'll give you one example for the policy. Okay. So I'm going to take two routers. These are some we have some commands and all with that. That much command, that commands for configuring your quality of service, how to specify your data, how to classify your data. When you come into the ASA firewall, security topic, in ASA firewall, that ASA firewall module will learn how to specify your data, how to classify your data, how to set the priority. And this I'm going to just show you how to set your limit for the data. I want to receive only this much amount of data. So first, basic configuration, assign the IP address and all. R2. 0, then IP address 192.168.1.2. First, check the reachability in 192.168.1.1. So we have reachability. Now I want to increase my data, increase my size. So this is your datagram in the bytes. I'm going to send 1,000. We can send our data. And 2,000. To repeat in 100. Continuously we can send multiple data. 1,000. Without losing any packet, we can send multiple data at the same time, continuously. We can see 1,000. No issue. We have to avoid this kind of scenario. I'm going to set some limit. At the same time, I'm going to receive only 1,000 bytes of data, not more than that. If you are trying to send more than that, so extra packet, I'm going to drop. Okay, policy. So to configure something. First, we have to classify our protocol. First, classification. So with the class map, we have one concept, class map. In the class map, match. We have to match our protocol. So this much protocol I can specify there in the classification. Lots of things. This is that's why I told you, we don't have any configuration part in the CCNA. You have to learn this configuration part in the ASF line. And I'll give you the one example. That's it. But with the example, we can get the idea, concept easily. So, match protocol. So I'm going to classify my assembly protocol. Exit. Now policy. I'm going to specify the rate. Policy map P. Here we have to define our class. Then here I'm going to specify my policy. I'm going to specify my range, like this much data I want to receive only. After that, drop that packet. Targeted bit rates, bits per second. So I can specify 100. 100. 10,000, because minimum is 8,000 bits. It's not a byte, it's a bits. That's why. So I'm going to specify 10,000 bits. Then between this range, we have to tell our router, like in the access list, we have deny and permit. If you are, like, if I say IP, if I am receiving 192.168, if I am receiving any packet from 192.168.1.1, drop that packet. Then also when you are creating one deny packet, deny traffic, deny access list, then implicit deny by default is creating in your router. So we are saying in a second parameter, in the second access list, we are saying allow IP address any, except this IP address, allow rest of all traffic. Similarly, here we have to say, like, when you are receiving data below this range, we have to transmit that data. After that, deny. So we have confirm action less than confirm burst. So first confirm action, transmit. Second one, we have to use exceed access. And here I'm going to use drop. So I classify my data, I set my bit range. Now, as like same like access list, we created access list, and after creating your access list, we have to apply on particular interface, on a particular direction. Similarly here, I created some policies and profile. Now we have to apply on some specific location on the interface. That's it. And I created in R1. So in the R1, my interface is G0 by 0. So come to the interface G0 by 0. Service policy. Command is service policy. Input, we are receiving our data like direction. Your policy map name, P name. Now, the class map and the policy. Now try to send the data. I'm going to send only 10 packets. We are sending 2000 bytes. And there we set only 10,000 bits. When you are converting your byte into the bits, so it's very large data. So like this, we can specify our protocol, or we can specify our bit speed. But when I'm trying to take a telnet access, so okay, not an issue. So when I'm trying to take a telnet access, so for the telnet access, we don't have any limitations in it, so we can send multiple data. No, we just set that bit range just for the ICMP. With the class map, we can classify our data. With the policy map, we can set our range, we can set our bit rate, we can set our XN, what you want to do, deny or transmit, or what you want to do. Like we can put in a queue, or you can put in the buffer end. So in the policy map, you can do that kind of stuff. So this is your quality of service. It's just a one demo. Speed. So it's going to receiving some traffic. It's going to drop extra traffic. So this is your quality of service. Mainly in the depth, like how to configure extra policies, maybe enterprise level, you will learn these things. According to syllabus, this is your quality of service.
Can you show this R1 configuration?
Configuration. Okay.
So just for testing purpose.
Okay, no,
on
it's
CNA.
no, it's so,
Yes.
first class map, then your class name, forget about this one, then match protocol, ICMP, then policy map, P map, then we have to define our class, then policy, then confirm action, and exit. Then we have to apply our policy map on one particular interface. Yeah, like in the class map, we can classify your protocol and services, and what kind of data you want, what kind of action you want to perform Like you want to set the bandwidth, you can set the traffic, all in the policy. Like policy, we have to create our policy. Yeah, in the class map, we have to classify our data. This is my ICMP protocol. This is my web service. This is my traffic. This is my access list. Access list also you can define in the class map. Define क्या तो यार ले लिया ना it's all belongs to the security part. This come to the AS policy is a policy. This is your policy. Okay, done, guys. So our next topic is like relax. I see IPv6. Like in the second or third class, we learn about the IPv4. Similarly, IPv6. Subnetting. Okay, so guys, I have a question. Why they introduce IPv6? We have already IPv4, so why they introduce IPv6? Competition. It's a limitation. It's a competition. Why they introduce IPv6? Like in the IPv4, we have some limited set. Like how many IP addresses we have in IPv6? IPv4? IPv4. IPv4. In IPv4, like how many bits we have? 32. So 2 raised to 32. Calculator is good. Two raised to 32. Only this much now. Only this much IP addresses we have. Okay. In IPv4, total class A, class B, class C, class D, total this much IP addresses we have. And how many people we have on our earth? How many devices we have? Like with me, I have one laptop, one PC, one more mobile in my bag. Okay. So currently I have 3 devices, and in this PC, sometimes I have one VMware. So in that VMware, I have some different like I have a ESXi. In the ESXi, I deploy some different operating system, Windows, Linux. Around 5 to 6 operating system I have. So for that, I have to allocate some different IP addresses. So we have limited IP address in our IPv4. So that's why they introduced IPv6, because we have very limited IP address. Nowadays, I don't know, like in a Bangalore, they are using IPv4, IPv6. Yeah, still they are using IPv4. But in the Geo, if you have a Geo SIM card or Geo fiber net, so the Geo is using IPv6. In a Surat, mostly we are using IPv6. Here they are using IPv6. In IT city, they are using IPv4. So let's come to the theory, IPv6. So in IPv4, how many bits we have? 32. In IPv6, 128. So how many IP addresses we have? 2 raised to 128. So 2, there is a rest, raised to 128. Pronounce in the normal word, like is a billion, trillion, or what is it? What the meaning of E? Huh? Value of E. Just find the value of E. Okay. So we have lots of IP addresses in IPv6. Now in IPv4 is divided by the dot. Okay. We have 4 groups in IPv4. So, okay. 4 octet. IPv4. In IPv4, we have 32 bits of data. That 32-bit data is divided into 4 parts. In each and every part, we have 8 bits of data. Okay. Now in the IPv6, we have 128 bits of data. Bits of data. So this 128 IPv4 is divided into 8 groups. IPv4 is divided into 8 groups. 8 groups. 8 groups, like this. IPv6 1, 2, 3. Like this, we have IPv6. Okay, your IPv6 is divided by column. Okay. Now IPv6 is divided into the 8 groups. In one group, we have 4 hexadecimal number. 8 group. In one group is equal to 4 hexa number. Hexadecimal form. Hexadecimal form. Okay. What is the binary number? Binary format. The binary format, what more? 0s and 1. In the decimal, 0 to 9. So, yes or no? No. In hexadecimal, 0 to 15. Or 0 to 9 and A to 8. So, in a binary, we have 0 and 1. The two values we have 0 and 1. In the decimal, we have 0 to 9. In the hexa number, we have 0 to 9 and A to 0 to 9. Okay, and A to F. Okay, 0 to 9 and A to F. Okay. And in one hexa number, how many bits we have? In one hexa number. One hexa number is equal to 4 bits. So one hexa is equal to 4 bits. Okay. So in one, huh? 0 to F. So first binary is 0 to 1. Okay. Decimal start from 0, then 1, 2, 3, 4, 5, 6, 7, something. 12, 13, 14. If I'm converting this value into the hexa number, so 0 means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then A, B, C, D, E. Like this we have. Okay. Now if I'm converting this data into the binary, first one is over 0, is 0, 0, 0. Now this one is our hexadecimal number. I want to convert into the binary. So one hexadecimal number, one hexa is equal to 4 bits. When 0, it means how many? 0, 0, 0. 0, 4 times 0. Then 0, 0, 1, then 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1. No. Like this is 0, 1, 1. Then 4, then 5, Yeah, that's correct. Then 0, 1, 1, 1, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So this is your binary conversion of the hexanumer. First one is a decimal, second line is a hexadecimal, and the third one is a binary format of hexanumer. Okay. So 1 hexa is equal to 4 bits. So in one group, we have a 4 hexadecimal number. Okay. It means 4 into 4 is equal to 16. It means in one group, we have a 16 bits. So total, how many groups we have? 8. 16 multiplied by 8. What is the value? 120. So correct formula. Now, we have some data. This is your IPv6. So this is your IPv6 address. Just give me a minute. I just started. Just give me a minute. I just started my concept IPv6. So this is your format of the IPv6. Okay. It means we have 128 bits. We are dividing that 128 bits into 8 groups. In one group, we have a 4 hexa number, and that 1 hexa number it's a 4 bits data. Suppose I have one number. So this is the one format of your IPv6. Okay. I have one question for you guys. Suppose you have 10 rupees. Okay. You have 10 rupees. Now how much rupees you have? Then. So this 0010 I can write directly like this 10. Suppose you have this amount 0010. So directly I can write like I have 10 rupees. Okay. Suppose I have this value. Can I write like this? No, because it's 1,000 rupees and I'm saying okay, it's 1 rupees. So it's not possible. So we can, like, if we have a 0010, it means we can remove that 20, the first 20. Clear? Same like if we have a 0000, 4 times 0. So directly I can write like 10. Clear? So this is my second format. I can write ABCD, then 2147, then 10, then 1, then 100, then CD, then 0, code 0. So I can write like this also. This is a valid IPv6 address. Now here you can see I am receiving the continuously 0, continuous 0. Like suppose if you have here also 0. So continuously I am receiving 3 times 0. So I can merge that 3 times 0 like this. Two times column. When you are denoting 2 times column, so in your system is going to recognize like, okay, I have 2 times column. So it's going to count how many groups we have. 1, 2, 3, 4, and the 5. In this we have 5 groups, and the total we have 8 groups. So remain 3 groups, we have a 0. Okay. Suppose I have one number like this here. One, 2, 3, 4, 5, 6, 7, 8. So directly I can write like this: ABCD colon 2147 colon 1, colon 1000. So your IP, your system is going to calculate like one group, 2, 3, and the 4. Total we have a 4 groups. Total we have 4 groups. Okay. So how many groups we have in IPv6? 8 groups. And here I have only 4 4 groups. So remain 4, 0, it's here. Or if I forget here 10, like this. So remaining 3 groups, 3 zeros, this belongs to here. Suppose you have one more value. One, two, three, four, five, six, 7. Okay. Can I write like this? ABCD colon 2147 colon 100 colon. Can I write like this? No. Why? Then why? So like according to like I have 1, 2, 3, 4 groups. Okay. As of now, I have a 4 group. It means remaining 4 groups is 0. So on the first location, how much zeros we have? 1, 2, or 3, or 4? We don't know. Like here, how many zeros we have? We don't know. That's why in IPv6 you can use only one time you can use this 2-time column. If you use this 2-time column first, then here you have to mention like this. Then we can recognize, okay, we have 6 groups, so remain 2 groups is a 0, and here we have to put that 2 times 0. So like this, you can write your IPv6. Anywhere. So this is your IPv6. Like this, you can write. Clear? Now, in the first or second class, we learn like for any unicast, multicast, and the broadcast. What the meaning of unicast? One-to-one communication. Multicast, one to particular group. Broadcast, one-to-one. In the IPv6, they remove this concept, broadcasting. We don't have any broadcast concept. We have anycast, 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 anycast. Okay. So generally, like in the IPv4, we have unicast, multicast, broadcast. Okay. But in the IPv6, they remove this broadcast and they introduce unicast, anycast. Okay. So what's the meaning of anycast? I have one router. The router is connected with the ISP, and ISP is connected with your like internet. We have definitely, with the help of the ISP, we have an internet connection. This one. Here we have one Google server in India branch. This is your India location. One more DNS server we have in Australia or UK level, different country. It's a different country. The connection look like this. Now just tell me, can I assign multiple IP address? Like here I have one Google server. This is your server. This is your router. This is your ISP. And also this one is also server. Can I assign IP address 8.8.8.8 in IPv4? This one is a Google server IP address. So you can assign. Can I assign same IP address here? No. In the IPv4, we can't assign the same IP address to different devices. But in the IPv6, we can. So in IPv6, we can assign. So here I am going to assign one IP address 2001::1. This is my one of the IP address. The same IP address I am going to assign here. We can assign like this. Now, this thing like when you are when I'm trying to reach to the server like 2001 colon 1, it means your request is coming from router. It will reach to the ISP. Then your packet will reach here or here. This is your India location and this is your UK location, and you are belongs to in India. So your packet will reach to the India location DNS server. When this one goes down, then it's going to forward your packet here. It means first come first serve. You can assign the IP address to multiple devices. When I am trying to reach my DNS server, so first is going to reach to the nearest destination. If my nearest destination goes down, then it's going to check your second nearest destination. This is called a anycast. Got it? It's going to check the nearest destination. We can assign the same IP address for the DNS servers, like multiple devices. We have some different concept. Like in this scenario, we can assign an IP. As of now, just anycast, it means we can assign the same IP address to multiple devices. When you are trying to reach your destination, so first your packet will reach to the nearest destination. When your nearest destination goes down, then it's going to check your second nearest destination. Clear? This is your anycast. Clear this one? Now my second question. The second question is, in a CCNP, you have a 3 weeks class for the advanced routing. Okay. In that advanced routing, you are going to learn about the IPv6, like RIP with the IPv6, ERGIP with the IPv6, OSPF with the IPv6, and for 3 weeks. 3 weeks or 2 weeks, I'm not sure timing. Now my question is, I have 2 laptops. Okay, I took the 2 laptops, I connected with the cable. Okay. Do we have reachability? I didn't assign any IP address. I told you, like I took 2 PC and connect the cable. Do we have reachability in this scenario? If I say yes. In the IPv4, no, we don't. It means like when I select laptop, when I select DHCP, so it's going to receive if I wants to send the packet to specially to the location hub. Suppose in like you are trying to send a packet like we are using the DNS server 8.8.8.8 we are generally using, and 4.2.2.2 we are just using that specific, we are just using that server. And in the IPv6 we can assign the multiple IP addresses also. If you want to reach specific locations, then you can use separate IP address. You can't specify the specific location. Okay, I want to send my traffic not this server, specific this one. If you want to do like this, so you can assign the different IP address. They just introduce anycast for this DNS servers and all, because in each and every country we have a DNS server, and the Google has a different DNS server in the different location. So why they are wasting their IP address? They can specify only one IPv6 IP address, and everyone can use it. If anyone who's trying to access that DNS server which belongs to in India, you can reach that. When your India DNS server goes down, then your packet will be redirected to the Australia or some other. You can specify like location. If you want to specify, you can specify the different specific IP address. Okay. Now, do we have reachability? Laptop configuration. If I use DHCP, so we are receiving one IP address. One IP address 98.114. Yeah. So we are receiving some IP address. Okay. But do we have a reachability with this IP address? Do we have reachability with this IP address? With the people, you can't communicate from one location to another location. We can't. In the IPv4, we can't communicate with these people. But I need a reachability. Now with the IPv6, yes, the IPv6 we can. I didn't assign anything, but like a PIPA, your system is going to generate one IP address. Similarly, in the IPv6, your system is going to generate one IP address, and with that IP address, you can communicate. Like this, my laptop. Interface F0 by 0. This is your IP address. Copy this one, come to the second laptop, and try to reach. So yes, we have a reachability. I didn't configure anything, but we have a reachability with this IPv6 address. Now the second question, why they calculate this IP address? And suppose I'm calculating some IP address. Okay, so maybe I can calculate the IP address like 8.8.8.8, and my second PC also is going to calculate that IP address. Maybe he is calculating as 8.8.8.8. My point. But in the IPv6, in each and every PC, we have different IP address. There is no duplication. So how they are calculating the IP address? Based on the MAC address. So we have some formulas. Based on that formula, they are going to calculate this IPv6 address. And this is your genuine IPv6 address. How many groups we have? 1, 2, 3, 4, and the 5. And here we have 2 columns. It means rest of 3 zeros we have here. Okay. So first, let's find how to calculate this IP address. So come to the laptop. Interface. This is your MAC address. What's first? IPv6. This is the formula. Let's try. Notepad. This is your MAC address. Just copy this MAC address. Paste here. Now, based on the MAC address, is going to calculate your IP address, and this IP address is called a link local IP address. This FE80, starting from FE80 2 times colon, it means it's your link local IP address. But with the PIPA we can't communicate, but with this we can. Now, what is the first rule? We have to add FFE in the mid of the MAC address. MAC address length is a 12 digits. Okay, we have to add this triple FE in the mid of the MAC address. It means after the 6th digit. Copy this one. You can see 4, 4, 4. It means 12. We have to add here after 4, 41. Yes. First one is done. Now the second, inverse 7th bit. In the IPv6, we have 8 groups. In 8 groups, we in one group we have a 4-digit hexadigit, and one hexadigit it means 4 bits. So suppose this is your IPv6. It means your first digit it's called a hexadecimal number. So we have to inverse our 7th bit. It means we have to convert these hexadecimals into the binary first, then select the 7th bit and inverse it. It means the first 0. First 0, what is the binary? 0, 0, 0, 0. Then second 0, again 0, 0, 0, 0. So I can write like this directly. This one, this one. 4, 5, 6, and the 7. This one is your 7th bit. Inverse it. It means reverse. 1. Okay. Now again convert into the hexadecimal form. So 4 times 0 it means 0, 0, 0, 1, 0 it means 2. And the rest of all just copy the paste it. And out in this, the second step. Okay. Second step is done. Come to the third. Add FE80 in starting. Copy this one and paste into the starting. remove these dots. Now, in one group, how many bits, how many digits we have? 4 digits. So 1, 2, 3, 4. And your IPv6 is denoted by, like, is divided with column. 2, 3, 4. So how many groups we have? 1, 2, 3, 4, 5. In IPv6, how many groups we have? 8. It means the remaining 3 bits is a 0. 3 groups is 0. So where we have to put that column? After the first segment. After the first segment, you have to put column. Like in this scenario, I have 4, but in this scenario, I have 5, but here I have 1, 2, 3, 4, 5. It's a 5. So 5 groups, but in the IPv6, we have 8 groups. So we have to add colon after first segment. So FE80 is your first segment, just add 1 colon. Now how many groups? 1, 2, 3, 4, 5, and the rest of all 2, 0, 3, 0. This value I can write like this also. I can remove this 0. Now come to the laptop 1. Check your link local IP address. Exact same data. Okay. And in your system, like we have a different MAC address for the different NIC cards, and there is a separate NIC card. We don't have any 2 MAC address in the same PC channel. It's a different. So that's why when your PC is going to calculate your IPv6 address, so it's a different. There is no common, there is no duplication of IPv6. And with this IP address, we can communicate from one location, one device to the another device. Clear this one? Note it down the steps. First, add this value made of the MAC address, then invert 7th bit, then add FE80 in starting, then add 1 colon after the first segment. Or you can keep the bit. I'm going to read over. Okay, so guys, so next task is we have to configure our static route with the IPv6. Only the static route. Okay. So take a two routers. Your configuration is remain same. Just we have to replace our IPv4 to IPv6. Like if you want to assign the IP address, so what is our command? Like come to the interface mode, then IP space address. So instead of IP, just we have to mention IPv6. That's it. Separate specific location. I'll say. I'll tell you. Now this is your router. Come to the interface G0 by 0. Interface F0 by 0. Now first we have to enable our IPv6. IPv6 enable. Without this one also it's working, but sometimes it won't work. So IPv6 enable. Now we have to assign the IP address. So IPv6 address 2001::1. Like in the IPv4, we have our network bits and the host bits. Remember? In the class A/8, class B/16, and the class C/24. So here in the IPv6, total how many bits we have? 128. So by default, first 64 bits is a network and the last 64 bits is a host. We can change it. /64. Here. Now, in the IPv4, if I want to check the IP information, what is the command? In IPv4, if you want to check your interface IP address, so IP interface bit, this is your command. But here we don't have any IP address, but your status is up. So just replace your IP to IPv6. So this is your IP address, 2001, and this is your link local IP address based on your MAC address. Now come to the router 2. Send command. Now, enable interface F0 by 0. Shut down. IPv6 address 2001::2/64. This one also we can communicate, depend on the devices. If you are not getting the reachability, then we have to fire that command. Like without enabling, let's try. Do we have reachability or not? Ping 2001::1. You can say we have reachability, but in some case we are not getting the reachability. So we have reachability. Here, what's my IP address? I saw IPv6 interface with 2002, and we are getting the reachability. Now in the router, in this router, I'm going to create one loopback. So same command, interface loopback to 1. Then IPv6 address 2002::1. Only a bit no second. 5. Then check so IPv6 address, so IPv6 interface group. Our interface IP address, our loopback IP address, and our link local. Now, from the first router, I want to reach here 2002 from here. So directly we don't have any reachability, like 2001::2 directly connected, so we have reachability, but we don't have reachability with this one. We don't have any route. Let me check. So IPv6 route. This type, so IPv6 route. So IPv6 ROE. So directly connected, so we have reachability. We don't have any information about the 2002. So for that, I'm going to create one access static list, static route. So similarly, in the IPv4, we are firing IP route. IP route, then source like destination network, then subnet mask, and then exit interface or your next hop. Similarly, your syntax is remains same. Just we have to replace from IP to IPv6. Like here, IPv6, then out, then 2002:0. So that's 64. Now I'm going to view my next hop 00::2. Check your route. So IPv6 route. So we have one static one. Now let's try to communicate. Ping 2002::1. So we have 0. This is your IPv6. I have one document. If you want, you can use this one. One more thing. Like you can see, there is a no broadcast traffic, mobility support. What's the meaning of mobility? Not mobile. Mobile. We can, if I assign one IP address to my device, okay, the IP address belongs to my device. If I'm sitting here, so I can use the same IP address. If I went to the cafeteria area, my IP address is remains same. This mobility, we can take a mobile and leave it. Simple. That IP address is fixed for your PC. If you are sitting here with that IP address, you can use internet. If you are bring your laptop to some cafeteria area or some different location, like still your IPv6 address is remains same. Because we have lots of IP address in the IPv6, we can assign one particular IP address to our particular device. I can assign one IP address to my PC, to my mouse, to my mobile, to AC. We can assign specific IP address. We can assign it. Now this one you can see the non-net PET required. Generally in IPv6, why we are using the translation for translation. Yeah, in our environment we have multiple users and we need the internet connectivity. We can't purchase the public IP address, it's costly, and the second thing is very limited. In IPv6, there is a lots of IP address. We can assign one separate IP address to the one device, specific IP address to specific device. So that's why no need to translation. But if you want, you can. We have that feature, but no need. Then also we have like field header. In the IPv4, tomorrow we are going to discuss this IPv4. In the IPv4, we have 13th field. IPv4 header. So like this, we have 13 different fields. Version, header, types. Like this, we have 15 fields. But in the IPv6, we have only 8. Only this one. So we have a less number of address. And like we can't, this one, migration tool from IPv6 and IPv6 are not compatible. Means directly we can't communicate from IPv4 to IPv6. We have to do some configuration. Directly we can't communicate. Okay. These are our normal information for hexadecides from 0 to 9, A to F and all. This is the format. Like this we can write network portion and the host portion. Then remember in the IPv4 we have what the loopback IP address range in the IPv4? Loopback
127.0.0.
127.0.0.0. Entire network they introduced as a loopback, but we need only one IP address for checking our website, local website. Like in a computer engineer, we have to create some websites, and first we have to host that website locally on our PC. So we are using the loopback address. So for that kind of task, we need only one IP address. But in IPv6, IPv4, they reserve entire network for the loopback. It's a vestige of IP address. So in the IPv6, they are working this one. We need only one IP address, so they define first IP address as a loopback IP address. In IPv6, we have an entire 127 network for the loopback. But here we need only one IP address. So in the IPv6, they introduce only one IP address for the loopback. And this one is unspecified binary 0000. In IPv4, we are using first IP address. Generally, we are not using for the default route. We are using it. Similarly, in IPv6. Then we have link local FE80. This one FE80. So it's called a link local. Then we have some multicast IP addresses, like for the OSPF, we have 224.0.0.5. So we have specific range F02::5. Means Swati part. So your IPv4 is like FF00:, it means the first 8 bits is going to reserve for the multicast. Okay. Like in the IPv4, we have which one? 224 to. What is the range for the multicast IP address? 239, I guess 224 to 239. So that range is reserved for the multicast. So here we have the initially 8 bits for the multicast. FF00::. So initially first 8 bits is reserved for the multicast. FF:, just check this value. Okay. Then like this, we can assign the IP addresses. So this is your IPv6 and addressing or subnetting like up to 64/3 is a global, 16 registry, ISP, they are using /32. Some information. So guys, this is your IPv6. We don't have classes. There is no classes concept. Just increase your number and you can do subnetting. We don't have actually that subnetting. Normally, as of now, we are not using, but after a few years, definitely we are going to use, because nowadays companies are moving towards the IPv6. Take some time. How it took the access? I didn't give any permission. Okay, guys, so this is our classes like IPv6 and the quality of service. Any doubt, any query in this? Don't worry, like when you come to the CCNA, so we have 3 weeks class for this advanced routing. In that, you are going to learn the routing, IPv6 routing with the read, with the ERGRP, with the OSPF, maybe with the BGP also. Okay, it's just an introduction like how we can write our IPv6 and how can we configure it. That's it.
Sir.
Yeah, what happened?
Sir, can you share that PPT?
Yes, I'll share this PPT today.
This one and wireless PPT.
Sure, I'll share.
Wireless document.
Okay. Okay then. This is my class. Tomorrow we are going to discuss about the OSI model. Okay, then tomorrow
one moment, sir. I have a doubt.
Yeah.
You said in IPv6 we assign a same IP address to different devices, right?
Yes, you can assign.
Okay. So if I'm like assigning the same IP address to 2 devices, A and B, example, if I want to send a packet to B, how to do a specific way of sending the packet to this?
Options. Like suppose here I have one more device. And I assign the same IP address, so we can communicate from here to here only. From first to second, you can't connect. You can't communicate from first to third. when your this router goes down and we have a connectivity with the third, in this case only you can communicate from 1 to third.
Okay. Okay.
Because
Yeah.
we are communicating based on the IP addresses, and IP addresses remain same. So when you are sending your packet, so first it's going to reach to your nearest partner. When your nearest goes down, then we can move to the second one.
Okay. 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 Got it. Thank you.
Different IP can communicate with these two, but the same two servers will not communicate. They these two routers having the same IP, so they will not communicate with each other.
So for that, they can use some different IP address. Like generally, this same IP address like unicast topic we are using for the DNS purpose only. Because in the
Okay.
DNS server, like why we are using a DNS for resolving the IP address, and in each and every country we have a DNS server. So for the DNS purpose, we can use the same IP address. Like in each and every area, we can use same DNS IP address. In India, like we are using 8.8.8.8, then 4.2.2.2.2. So if you are moving from India to US, so you can use the same IP address for getting the initial 8.8.8.8 DNS server. Generally, in this scenario, we are using.
Okay.
Okay, then tomorrow OSI model and DNS server. Okay, then see you tomorrow.
Thank you.